we come up to, do you remember? You finish 12 sum.
Sir.
It means 13, 14, and 15 we still have to do. Yeah.
Yes, sir.
We have to do 13, 14, and 15. Then only we can move to coefficient of variation. So let us try to do 13, 14, and 15 sums now. We'll do it in class. Then we'll do the introduction to coefficient of variation. Okay.
Okay, sir.
And work out some examples. Exercise 8.2 is easier, only 8 sums. Okay.
Okay, sir.
Let us see whether we can start 8.2 today or tomorrow. We have to do something. So tomorrow, can you come in the morning for an extra class we missed out Wednesday?
No, sir. Morning I got online class, sir.
You're having class, huh? 6 days
Yes,
a week you're having class.
Yes, sir.
What about 3 to 4?
Yes, sir. I can come in 3 to 4, sir.
Okay, 3 to 4 tomorrow we'll do that then. Huh?
Okay, okay, sir.
Okay, 3 to 4 we'll do. And coefficient of variation, those exercise we try to do tomorrow, 3 to 4. I'll just then put that in your tomorrow, Saturday, 3 to 4 p.m. Only tomorrow alone like that, huh?
Okay,
Otherwise, we will continue as usual. Okay. Well, let us start 13 sum. 13 sum says it's very much similar to 12 sum.
Okay.
Okay, let us do the 13 sum now. Wait. Like that. Hmm. Thirteen sum, the time taken by 50 students. So 8.1, 13 sum. N is equal to 50. Much better. 100-meter race are given below. Find the standard deviation. Okay. Now class. This time taken. 8.5 to 9.5 seconds. One class. Then 9.5 to 10.5, another class. 10.5 to 11.5, another class. 11.5 to 12.5, another class. 12.5 to 13.5, another class. Okay. Now these fellows are all there. You can find the mid value now. Before that, number of students, this is F. Let us see F now. S is 6 for this fellow, 8 for this fellow, 17 for this fellow, 10 for this fellow, 9 for this fellow. So sigma F equal to N is equal to how much? 9 plus 10, 19. 19 plus 17, 19, 29 plus 36. 36 plus 8, 44. F is 50. Sigma S is 50. Okay. That's correct. Now we have to find the mid value. 8.5 to 9.5 is 9. To find mid value. 9. 9.5 to 10.5 is 10. This will be 11. This will be 12. This will be 13. The mid value is very easy. Now what you have to do, assume one mean. You have to assume mean. From there only you can get d of I. X of I minus a. You have to find. What mean we can assume, man? And we assume 11 because 11 is mid value. We'll assume mean as 11. We'll assume mean as 11.
Yes,
So
sir.
9 minus 11 minus 2. 10 minus 11 minus 1. 11 minus 11 0. 12 minus 11 1. 13 minus 11 2. Okay, we got assume mean. Then we have to find the fi, f of I, d of I, fi di. F into d. 6 into minus 2 is minus 12. 8 into minus 1 minus 8. 17 into 0 0. 10 into 1 10. 9 into 2 18. Sigma fi di you have to find.
Okay.
Sigma fi di is 18 plus 10 is 28. This is minus 20. Minus 20 plus 28 minus 20.
Okay.
28 minus 20 is equal to plus 8. So we will put this as plus 8. Now you have to find out fi di squared. To find out fi di squared. So di squared is equal to minus 2 into minus 2, 4. 4 into what? 4 into 1 into 0 into 1 into 4 into f 6. So 24. 6, no, this one 6. Okay. Then 1 into 8. F 1 into 8 is 8. 0 into anything 0. Again 1 into 10 is 10. Then 4 into 9 is 36. 36 plus 10, 46. 46 plus 8, 54. 54 plus 24 is 54, 58, 68, 78, I think. So sigma fi di squared is equal to 78. Now formula for SD is equal to root of sigma fi di squared by n minus fi di by n the whole square. Fi di squared is 78. N is 50 minus fi di is 8. 8 by 50 the whole square. Correct?
Yes,
8 by 50 the whole square. Now let us use our calculator. 78 by 50 will give you 1.56. Because 28 will be remainder. Okay. 8 by 50 will become 4 by 25. 0.16. 0.16 square. Okay. So that is equal to 1.56 minus 0.16 whole square will become very small. 0.025. Okay. So 1.560 minus minus 0.025 will become 5 minus 3, 35. Correct?
yes, sir.
1.535. So 1.535. That is equal to root of 1.535. How much is root of 1.535? Can you calculate?
1.535, sir.
Root of 1.535.
Root of 1.135. 1.06, sir.
No. Do correctly.
1.535 correct.
1.535. Square root of 1.535.
1.535.
Uh,
1.23, sir.
1 point, it will come 1.23 something.
Oh, yes, sir.
1.238. 1.2389 actually. So on the 89 round of panina 1.24. This is the sum. So
Yes, sir.
this is just like the previous sum that you did. So it is very easy. I'm going to paste this in your WhatsApp now. Okay. The next two sums are very interesting sums. Next two sums very interesting. For a group of for a group of 100 candidates, the mean and standard deviation of their marks were found to be 60 and 15 respectively. Okay, this is exercise 8.114. Okay, n is equal to 100. Mean x bar 1. Okay, 60. Okay, and S1 standard deviation 1 is 15. Okay, now x bar is equal to sigma x of I by n is equal to x bar. Okay, therefore sigma x of I by 100 is equal to 60. So sigma x of I is equal to 60 into 100 is equal to 6000. Sigma x of I equal to 6000. That means x of I x1 plus x2 plus x3 up to x100 is equal to 6000. Okay, understand that?
Yes, sir.
Now what you have to do is telling later on it was found that the scores 45 and 72 wrongly entered as 40 and 27. Okay, actual score is 45. Okay, wrongly entered is 40. Then, 72 as actual score, wrongly entered as 27. That means you have to add plus 5 here, and you have to add plus 45 here. So you have to add plus 50 totally. So totally plus 50 you have to add to 6000. So 6000 plus 50 is equal to 6050. This is the real sigma xi. Okay. So new mean x bar 2 will be nothing but sigma x of I by n 6050 by 100. Okay. That is equal to 60.5. It is the new mean or corrected mean. You understand that?
Yes, sir.
60.5. Now let us come to SD. SD or sigma 1 is equal to 15. Sigma 1 is equal to the formula is sigma x squared by n minus sigma x by n the whole squared, the whole root. Okay. Now original one is this one. That means you square both sides. No, square both sides. This side also you square, that side also you square. 225. 15 into 15, 225. Sigma x squared by 100 minus, this is the old mean. Old mean. Old mean is 60. So 60 squared. Like that it is coming. Okay.
Okay, sir.
Now what you have to do? You have to take 100 the other side. 22500 is equal to sigma x squared minus 3600 into 100. Okay.
Okay, sir.
Or let's not do it that way. 225 plus 3600. This one becomes 60 into 60 is equal to 3600. Okay. Okay, so plus is equal to sigma x squared by 100. Okay. 3825 is equal to sigma x squared by 100. So 3825 into is equal to sigma x squared. This is the original sigma x squared. Now what you have to do is x squared, no? So the original x1 was 40 squared. You have to minus 40 squared and add 45 squared. Original x2 was 27 minus 27 squared and add 72 squared. Okay. What happens? Minus 40 squared is equal to minus 1600 and 45 into 45. 45 are 25. 4 5s are 22, 225. And 4 5s are 20. Over the 16, 18. 2025. Plus 2025. That one comes to. That means you have overall added that 425 is added there. Plus 425 is coming there. How? 2025 minus 1600 is equal to 425. 4 tricks. Okay. Same way, 27 squared you have to find out. 2 7 7s are 49, 2 7s are 14, 15, 17, 18. Okay.
Okay, sir.
7 7s are 49, 2 7s are 14, 18. Then 2 7s are 14, 2 2s are 4, 5. So this will become 9, 8 plus 2, 12, 5, 6, 7, 729. Okay. So this is minus 729. Then you have to do 72 into 72. This is 144. 7 2s are 14. 7 7s are 49, 50. So you have to 4, 8, 1, 5. 5184 minus 729. 14 minus 9, 5. This becomes 7. 7 minus 2, 5. Okay, then 11 minus, so become 4. 11 minus 7 is again 4. 4, 4, 5, 5. Okay. So 4, 4, 5, 5. So this one is plus 425. This one is plus 4, 4, 5, 5. Totally 4, 4, 4, 425. 5 plus 5, 10. 5, 6, 7, 7 plus 1, 8. 4 plus 4, 8. Now plus 1, 9. So you are coming 4980 extra.
Okay.
4980 extra. 382500. Okay. So what you have to do, 382500 plus 4980 will give you 80. 9 plus 5, 14. 4, 5, 6, 7, 38. So it is coming 3,87,480. 87,480. Anything mistake? So 38740. Okay. So this is the new sigma x squared. Now what you have to do, you have to correct the standard deviation. Okay. Wait, I'll just paste this and come back. First paste this. Three eight seven four. Okay. 387480. This is the new sigma x squared equal to. So new standard deviation S2 is equal to root of sigma x squared by n minus sigma x by n the whole squared. Okay. Now this is sigma x by n is nothing but your x bar. But this is the new x bar. Okay, new x bar is equal to 60.5. Okay, and the new sigma x squared is equal to 387480 divided by 100 minus 60.5 the whole squared the whole root. This will be your new sigma. Okay, those ones 3874.8 minus how much is 60.5 the whole squared? Use calculator. 60.5 into 60.5 is equal to 3660.25. 3660.25. Okay, so let us do that. 3874.8 minus 3660.25 equal to 214.55 root of. Okay, now you have to find root of 214.55. 214, sorry, root of 214.55 is equal to 14.65. That is your answer. Okay.
Okay.
Now in your guide there is a slightly different thing that they are giving. 20255184. Everything is correct, but it's coming to 380. 4880. Wait, we will calculate once, then we'll get the correct answer. 5184 minus 729. 45. This is correct. Plus 425. Oh, this is 4880. Okay, so 4880 means this will be 380. This will also be 380. This will be 73.8, 3.1. So this will reduce marginally. 31. What is log of 213.55, 14.61. Yeah, so 14.61 is the right answer. Okay, this also I'll put a screenshot so that you will have continuity and you can see. So this very important sum, man. Okay.
Okay, sir.
Okay. Now let us do, what sum was this?
Number
Exercise 8.114. Okay. Now we have to do exercise 8.115. Exercise 8.115. Okay, we have to do this. The mean and variance of 7 observation, x bar 1 is 8 and sigma 1 is 16. N is equal to 7. This is given. If 5 of these are 2, 4, 10, 12 and 14. Okay. X1 is equal to 2. 2. X2 is equal to 4. X3 is equal to 10. X4 equal to 12. X5 equal to 14. Okay, this is the given. Okay.
okay.
Find the remaining two observations. He's asking what is X6 and X7 equal to what?
Okay, sir.
Now, it's also a very interesting sum. Okay. Now, x bar 1 is equal to sigma x I divided by n. Okay. Sigma xi is equal to 2 plus 4 plus 10 plus 12 plus 14 plus x6 plus x7 divided by 7. Okay.
Okay, sir.
X bar is equal to 8. So you take this the other side. 2 plus 4 how much? 6. 6 plus 10?
16.
16. 16 plus 12?
16 plus 12. 18, sir.
28.
28.
28 plus 14? 42.
32.
So 42 plus x6 plus x7 is equal to, you take this the other side, 56. So x6 plus x7 is equal to 56 minus 42. How much is 56 minus 42? 4, 1. Okay, that is equal to 14. S6 plus x7 equal to 14. This is one equation you have got. Okay. So you got that equation. Now, the mean and variance. Okay. Oh, variance. This is variance. Sigma 1 squared. Okay. Then what you have to do now? That means sigma 1 squared means variance. X1 squared plus x2 squared plus x3 squared, like that. No, like that. Till x7 squared is equal to divided by 7 is equal to 16. So x1 squared is 4. X2 squared is 16. X3 squared is 100. X4 squared is 144. X5 squared is 14 into 14, 196. Plus x6 squared plus x7 squared is equal to 16 into 7. How much is 16 into 7? 6 sevens are 42. 1 7 is 7, 112. Okay. equal to 112. Now you have to do 4 plus 1, 2, 3, 4, 5, 6. 16 plus 4 is 20. 20 plus 100, 120. 120 plus 144, 264. 264 plus 196. 10, 9, 10, 16. 2, 3, 4. 460. Okay. So x6 squared plus x7 squared is equal to plus 460 is equal to 112. No, that's not right. That's not right. Huh? What you have to do, variance sigma 1 squared is equal to sigma xi squared by n minus sigma xi by n whole squared. Oh, that's what I forgot. Something I was doing wrong. Okay, so that means sigma xi squared. This is sigma xi squared. That means 460 plus x6 squared plus x7 squared by n. N is how much? 7 minus sigma xi by n. Sigma xi by n is how much? Sigma xi by n is 8. Okay. Minus 8 squared. That is equal to 460 plus x6 squared plus x7 squared by 7 minus 64 into 7 by 7. Okay. This whole thing will come now like that. Okay. So 64 into 7 is equal to how much? 28. 42, 44, 48. So let us go the other side. 460 minus 448 plus x6 squared plus x7 squared by 7 is equal to is given variance, right?
Yes, sir.
Variance is equal to 16. This is the correct thing. 460 minus 448, how much? 12. Okay. So 12 plus x6 squared plus x7 squared is equal to 16 into 7. 16 into 7 is equal to 42. 7, 8, 9, 10, 11, 112. So 112 minus 12 is equal to x6 squared plus x7 squared. This is 100 then. 100 is equal to x6 squared plus x7 squared. So this is equation 2. Okay. What was equation 1? x6 plus x7 equal to 14. X6 plus x7 equal to 14. So we got two equations. Okay. Now here you can do some manipulation. A squared plus b squared, like that you take it. So you take x6 squared plus x7 squared minus 2 x6 x7. Okay, or you take it as a you take a plus b the whole squared. Okay, okay, assume x6 equal to a and x7 equal to b. Okay, then what it becomes? 100 is equal to a squared plus b squared. And similarly, this point becomes A plus B equal to 14. Okay, A plus B equal to 14. A squared plus B squared equal to 100. Now what you have to do, A plus B the whole squared minus 2AB. This can be the same thing. Okay, A plus B the whole squared minus 2AB. What is that? A squared plus B squared plus 2AB minus 2AB. This 2 will cancel out, will come to the same. So that is why it is equal to 100. So that is why this is equal to 100. Okay. So A plus B the whole squared minus 2AB is equal to 100. Okay. A plus B is equal to 14. So 14 squared minus 2AB is equal to 100. 196 minus 100 is equal to 2AB. 100 you bring this side. 96 equal to 2AB. 48 is equal to AB then. Okay. That means B is equal to 48 by A. Now you got something very important. 48 is equal to AB. B is equal to 48 by A. Okay, now you come and substitute here. A plus 48 by A is equal to 14. Multiply everything by A. A squared plus 48 is equal to 14A. So you get a quadratic equation. A squared minus 14A plus 48 is equal to 0. Now solve for A. Okay. A squared minus 6A minus 8A plus 48 is equal to 0. A into A minus 6 minus 8 into A minus 6 equal to 0. So A minus 8 into A minus 6 equal to 0. Therefore, A is equal to 8 or A is equal to 6. Okay. So the values for A and B, the last two values are 6 and 8. Missing values. Okay. So also
Okay.
I'm going to print screen and put it for you. You have to move this side. This also I'll have to. Now let us go and okay, 15 sum also over now. Let us now deal with coefficient of variation. Let us see what that is. Comparison of two data in terms of the measures of central tendencies. Now, single data, you are measuring central tendency, single set of data. Now, there are two data. Okay. And now you have to measure the central tendencies and the dispersions in some cases. That will not be meaningful because the variables in the data may not have the same units of measurement. For example, okay, you are measuring the data set of weight. Then you are measuring the set of prices. Okay. How will they be the same? The mean is for kg, 8 kg and 1.5 kg. How can you compare with 85 rupees and 21.6 rupees? So you cannot compare the standard deviations of 1.5 kg and the rupees 21.60 directly. It doesn't make sense. Okay. So comparing two or more data for corresponding changes Relative measures of standard deviation have to be used. Absolute measures are this one. These are all absolute measures. Okay.
Yes, sir.
These are all absolute measures. Okay. So 1.5 kg standard deviation, 21.6 rupees standard deviation. How, what sense it makes to compare 1.5 kg with 21.6 rupees? You cannot. So you have to change all this from the absolute measure of weight, kg, and an absolute measure of rupees into a common relative measure without units. Relative measure without units. Okay. That is where coefficient of variation comes in. Okay. Coefficient of variation of a data is obtained by dividing the standard deviation by the arithmetic mean. It's usually expressed in terms of a percentage. This concept is suggested by one of the most prominent statisticians called Pearson. See, Pearson's coefficient is something that you will learn even in your 11th standard. Okay. So this
Okay,
fellow
sir.
is very important, Carl Pearson. Pearson's coefficient will come there also. So coefficient of variation is nothing but the standard deviation divided by the mean. Once you divide that, you can take off all the units, the kg or the rupees, the 3 you can remove it. Okay. So
Okay, sir.
instead you have to express it as a percentage. So here standard deviation is 1.5. Okay. So what you have to do, you have to divide that by mean, 15 by 80. Okay.
Yes,
So
sir.
what will that be? Divided by 5, 3. Divided by 5, 16. 3 by 16. So 3 by 16 percentage. Or if you put 1 50 by 8. Okay. Something, let us do calculator. Let us do calculator. 1.5 by 8 into 100%. 1.5 divided by 8 is equal to 0.1875. Okay. Into 100 to get percentage, that is equal to 18.75%. So the coefficient of variation is 18.75%.
Okay, sir.
Like that you can take. So first data you saw 1.5 by 8 is 18.75. Coefficient of covariation of the second data. What is the second set of data? Okay, that will be 21.6 by 21.60 by 85 into 100. What will that be? 21.6 divided by 85. That is 0.25. 0.254. 0.254 into 100 equal to 25.4. So that is 25.4%. This is 18.75%. Okay. From this, we can see that the coefficient of variation is higher for this and lower for this. Okay. It is lower for this. The data with lesser coefficient of variation is more consistent or stable than the other data. Okay. That means this kg data, standard deviation, is more stable. Okay. Whereas this other one is having 25%. This one is having only 18.75%. So 18.75% only is more stable. Okay. The data with lesser coefficient of variation, very important. So lesser the coefficient of variation, more stable. That means it is having less variation. Okay. Now let us consider two sets of data. We have to now consider two sets of data. Find the mean and the standard deviation of the two sets of data. Okay. How to find mean? Here very simple. Add 500, 900, 800, 900, 700, 400. When we add 500 plus 900 plus 800 plus 900 plus 700 plus 400 divided by how much? 1, 2, 3, 4, 5, 6 divided by 6. 4,200 divided by 6. So that is 700. Okay, so this is correct. Mean is 700. Same way, add up all of this sigma x and divided by again 1, 2, 3 by 6. You will get 420 here. Okay, so this is
Yes, sir.
mean. How to find standard deviation of this? You find sigma xi minus x bar the whole squared by n. That is how no standard deviation. Okay, what is the formula for standard deviation? Simple formula, mean based formula. Not this also. Sigma xi squared by n minus sigma xi then the whole square. Okay, that is the thing. If you use the square method, or you can use the other method directly. You can use the mean method. If you don't want to assume the mean. Sigma xi minus x bar the whole squared by n. Okay, that's all. The whole square root. Whole square root. Okay, that one you can find out. So you can find out the mean also that way. Once you have found out the mean, okay, then you have found out the standard deviation. So standard deviation is this formula. So standard deviation and mean you have found out. If we compare the mean and standard of deviation of the two data, we think that the two data are entirely different. The mean and standard deviation of B are 60% that of A. So mean of B is about 60% that of A. Okay, because of the smaller mean, the smaller standard deviation led to the misinterpretation. Okay. Okay, so you should not compare directly the light. So in order to compare the two data, first thing you have to do is find the coefficient of variation. Okay, first one is sigma 420 by 700 into 100 you first find. Then 114. Oh, sorry. This is mean, this is standard deviation. Okay, 191.5 by 700 into 100 you have to find out by 7. 191.5 by 7. Okay, that is equal to 27%. The second one mean is 114.9 divided by 420 into 100. Again, if you take that mean, that is also coming as 27.4. So you see, both the data are equally stable. But when you looked at it just like that, it looked like the mean is smaller and the standard deviation is smaller. Okay, so that means the second data, see this one. Okay, if you just look at it directly, it looks like this one is smaller and this one is greater. Okay, the standard deviation is greater for that one. Standard deviation is smaller for this one. Therefore, you'll assume that this is more scattered and this is less scattered. but they are two different data sets. Okay, two different values, units, everything. Okay. When you take the coefficient, then only you find that both of them are having same coefficient. Okay, relatively they are all same. That means both the data are in the same way. Okay, so
Okay, sir.
we got that. And so how to compare two different data sets with two different values? You have to use coefficient of variation. Thus, the two data have equal coefficient of variation, and since the data have equal coefficient of variation, we can conclude that one data depends on the other. But the data values of V are exactly 60% of the corresponding data values of A. So they are very much related. Thus, we get a confusing situation. So, get a clear picture of the data, we can find the coefficient of variation. That only we need coefficient of variation. So, looks like when you see visually, this one mean is 420, that one mean is 700. So this is only 60% of that thing. Okay. So the values are all less and all like that. You will start thinking, oh, this one standard deviation also less, that one standard deviation very high. So the second data is less than the first data. Like that you will think. But when you take coefficient of variation and compare the two data sets, both are 27.4% only. So both are equally varying. Okay. That is the advantage of coefficient of variation. Let us do one or two example. When did we start? We start at 4:20. No, we have 10 minutes. Let us do an example. So this is very simple sum. No need to do anything. Mean is given 25.6. Coefficient of variation, variance is given 18.75. Now we know that coefficient of variation is equal to PV is equal to sigma by x bar. What is asking? Find the standard deviation. This is what is sigma is asking. So we just multiply x bar by coefficient of variation. Okay. So that means 25.6 into 18.75 you have to multiply. What is the answer? Okay, 25.6 into 18.75. Answer is okay. What we left out was this is 100%, right? So 480 is answer divided by 100. Okay, 4.8 you will get. So why this 100? Because it is always percentage. Sigma by mean is always a percentage. Okay. So this you take that side, you have to take this also that side. So that will become 18.75 into 25.6 divided by 100 is equal to sigma. Okay, 480 divided by 100, that is equal to 4.8. Okay, very important. Okay. Don't forget that 100%, otherwise you are going to get wrong answer. Okay, shall we do one more sum? We have 5 minutes. Okay, we'll just do one more sum. Yeah. Now, following table gives the values of mean and variance of heights and weights of the 10 standard students of a school. Okay. Now you have to find out which one is more varying than the other. Height is more varying. Height is measured in centimeter. So you cannot compare directly. Height is measured in centimeter. Weight is measured in kg. Oh, how you will get absolute values? You cannot compare them directly. So you have to take the coefficient of variance. CV only you will have to calculate. Okay. So first one, this is sigma squared. Okay. So what you need is sigma only. Okay. So coefficient of variation is equal to sigma by x bar. So variance is 72.25. Okay, divided root of 72.25. Okay, so 8.5 into 8.5 will give you 72.25. Okay, or if you want to use calculator, you can use calculator. Let us use calculator. 70 root of 72.25 is equal to 8.5. Okay, now you have to do 8.5 divided by mean. Okay, but the mean is 155. This is for height, 155. Okay, again
Okay,
you have
sir.
to convert into percentage. Okay, 8.5 by 155 into 100 percentage. So that means 8.5 into 100 divided by 155. That is equal to 5.48 percentage. Okay, straightforward. So the variance, coefficient of variance for the heights is 5.48. Now we have to find the coefficient of variance for the weights. If you compare these two percentages, which one is higher only will show you that, okay, which is more varying. Okay. A higher percentage will mean that there is higher variance. Okay. Now, for second one, coefficient of variance 2 is equal to sigma 2. Okay. Variance is 28.09, root of 28 by mean is 46.50 into 100 you have to do. Okay, into
Okay,
100
sir.
you have to do. So let us do, what is the root of 28.09? Root of 28.09 is 5.3. 5.3 by 46.50 into 100. Okay, so 5.3 into 100 divided by 46.50 is equal to 11.397 or 11.4. Okay, this is 11.4%. That is 5.48%. So which one is varying more? Height or weight? Height is 5.48%. Okay, weight is 11.4%. Which is varying more than? This is for height, man.
Yes, sir.
This is for weight,
Yes.
kg. This is centimeter. So which percentage is more?
The
11.4 or
weight only,
5.4?
sir. The weight only, sir. 11.4.
11.4. So weight only is varying more. Weight is varying more. That is the answer. You have to tell. Okay.
Yes, sir.
That is what he would have also told. Very simple. 11.4. So he is putting the reverse. Height is more consistent. We should tell weight only is varying more. Okay. Like that.
Okay,
We'll
sir.
stop there because exercise 8.3 we have to start. Let us start that tomorrow. What time we are meeting tomorrow?
3 to 4, sir.
Okay, 3 to 4 tomorrow. We will be doing. Okay. 4 p.m. tomorrow. Good. Okay, then very good. Exercise 8.2 will start tomorrow. Let us do 3 or 4 sums and see how we can go. And if you are finding it, you are understanding it better, then we can start doing what you call homework also. You can start taking homework.
Okay, sir.
Okay. 8 sums are there. We'll try to do 4 sums. Then you can do 4 sums homework. Okay.
Okay, sir.
Yeah. Did anybody give you what is omitted, what is not omitted, all that in the school?
Yes, sir.
You sent that to me.
Okay, sir.
You sent that. You have already sent it. No, no.
No, sir. I didn't send it.
Okay. If you send it on WhatsApp, then we can see, because if statistics is omitted, we can omit it off
Okay,
and,
sir.
and see what has to be done. Okay. Let us go. But maximum we'll try to do everything because 11th standard you will need it. Let us see what
Okay, sir.
happens. What we
Okay,
can
sir.
do is let us try to cover what are all reduced portion first we'll try to cover, and then go and cover all the remaining things. Okay.
Okay, sir.
Please send me the reduced portion on WhatsApp, ma. PDF
Okay,
file or
sir.
whatever you have. Yeah. Okay. Right. Bye bye then.
Okay, sir.